Hello, grade 10. How are you today? I hope you're doing fine. So in this video is going to be the last part for dynamic electricity. We are going to talk about electric power, okay? If you didn't watch the previous videos, please watch them again because you're going to use a lot of variables that we discussed before, okay? So this is going to be the part 1, and then after I'm going to send you the part 2. So electrical power is the amount of work an electrical device can perform per second. It's the amount of energy it can transform in a certain period of time. So each device has its own job, let's say to move, to change something, to create, to deform something. And each of them has this electric power, this potence that he can perform the work, okay? The more powerful is the device, the faster or better it works, okay? So for example, a fan, if I have a fan that is more powerful, it means it can work faster, okay? And the delivery better, the movement. The more work a device does in a given time interval, the more powerful it is. Electrical power is a measure of the rate of transformation of the electrical energy. So we know, for example, for the fan, it's the electrical energy is being transformed to mechanical energy. And the rate of this transformation, or how fast the fan is moving, is what we say the electrical power. So we can have some fan that's more powerful and some that are not, okay? How do I measure this? So I symbolize this by P or just P sometimes, and I measure it in watts. Okay, watts. 1 watt is 1 joule per second. So here's the formula. 1 watt is 1 joule, that's the measurement of energy per second. So how much the energy has been transformed. A power watt of 1 watt is equivalent to the delivery of 1 joule of energy every second. So if I have a device that has just 1 watt, it means it delivers 1 joule of energy per second. And now how do I make this formula? So potential electrical power is PE, and we measure in watt. E is the energy that we measure in joules. And delta T is the time that we measure in seconds. But this power can also be expressed as a function of potential difference and current flowing. So remember potential difference, V, and current flowing, I. So please, if you don't know what I'm talking about, you need to come back to the previous video, okay, to learn about potential difference and current flowing. So potential power, PE, is equals to volts, potential difference, times current. So P in this equation is electrical power that we measure in watts, V, the potential difference that we measure in volts, and I, that's the current intensity that we measure in amperes. 1 watt is equivalent to 1 volt times 1 ampere. If you remember, volts is a measurement of joule per coulomb, and amperes is a measurement of coulomb per second. When I multiply both of them, I can cancel both coulombs. Now, what's left? Joules and second. So 1 watt is 1 joule per second. Okay, so these two are completely related. And you need one or the other to solve this exercise, and sometimes both. Okay, so let's do some examples to practice. Example 1. A fan has a power rating of 500 watts. If the fan is left on for 12 seconds, how much energy to use? So first let's highlight. So a fan has a power rate of 500 watts. If the fan is left on for 12 seconds, how much energy it will use? Then I'm gonna follow the same steps, okay? Make a list of the information provided. So here I have power, equals to 500 watt. I have time, 12 seconds, and energy that I want to find. Step 2. Choose the correct formula to be used. So as we just saw, we have two formulas. Power, energy over time, and power is voltage times current. Which one we should use this in this case? The first one, right? So this one. Step 3, replacing the formula. So I'm going to write down the formula. Power equals to E over time. 500 equals to E that I don't know, and time 12. Just remember that the time must be in seconds. And step 4, simplify and calculate. So I have here 500 equals to E over 12. So E 500 times 12. So E is 6,000 joules. Gonna read again. How much energy it uses? It will use 6,000 joules of energy. Okay? So the next one. A current of 5 amperes flows through a flashlight bulb when it's connected to 6 volt. What's the power of this bulb? Now let's highlight. A current of 5 amperes flows through a flashlight bulb when it's connected to 6 volt. What is the power? So let's make a list. I have current, 5 amperes. I have volt, 6 volt, and I don't know the power. Choose the correct formula. From these two, which one should you use? Second one, right? Replacing the formula, P is equals to V times I. Power I don't know, 6 times 5. And then simplify and calculate. So P 6 times 5. So P is equals to 30 what? Watts. What is the power of the bulb? The power is 30 watts. Okay. Next one. A kettle has a power rate of 2,200 watts. It takes 90 seconds to boil some water. Find the energy it uses in this time. So let's make our list. No, before the list, sorry, let's highlight. A power of 2,200 watts. It takes 90 seconds to boil. And I want to know the energy. Now, let's do a list. I have power, 2,200. I have time, 90 seconds. And energy, I don't know. Step 2, choose which one. So the first one. And step 3, replace the formula. So 2,200 equals to E over 90. And 4, simplify and calculate. So I have 2,000 equals to E over 90. So here I have 1. So E times 1, E, 2,000 times 2,200 times 90. So energy is going to be 198,000 joules. So find the energy used this time. So it uses 198,000 joules. Okay, next one. A 600 watts electric heater is connected to a 120 watt source. What current flows through the heater? Let's highlight. So I have 600 watts, 120 volts, and I want to know the current. Let's make our list. So power 600 watt, volts 120, and the current, I don't know. Now let's choose the formula. Which one should you use? Second one. Step 3, replacing the formula. So power V times I, power 600 volts, same 120 times I. And the next step, simplify and calculate. So 600 equals to 120 times I. Here is multiplying. I'm passing over there, dividing. So I is going to be 600 divided by 120. Cut, cut. So I is 5 amperes. What current flows through the reheater? The current is 5 amperes. One more. Mike's iPod plays a song that lasts 20 seconds. During this time, it consumes 100 joules of energy. Can you calculate the power rate of this iPod? So let's highlight. Mike's iPod plays a song that lasts 20 seconds. During this time, it consumes 100 joules. Can you calculate the power rate of the iPod? So let's make our list. I have time, 20 seconds. I have energy, 100 joules, and I want to know the power. Which formula should I use? First one, right? Replacing the formula. So power 100 over 20. And the last step, power 100 over 20. So power is going to be 5 watts. So what's the power rate? The power rate is 5 watts. And finally, the last one, okay? A 2.5 amperes current flows through a 100 watts lamp. What's the voltage across the lamp? So 2.5 amperes flows through 100 watt. What is the voltage? Let's make our list. Current 2.5 amperes, power 100 watts, and voltage, I don't know. What's the correct formula that I need to use? Second one. I'm gonna replace it. So power times I, power 100 equals to V times 2.5. So V, yeah, I'm doing the last one already. Simplify and calculate. 100 times divided by 2.5. So voltage is gonna be 40 volts. So what's the voltage? The voltage is 40 volts. Okay, so that's it for this first part, okay? Please do this first before you do the second one, because the second one is gonna be a little bit more complicated, okay? See you there, guys. Thank you so much for watching.